2017 Lean Start Higher Level Paper 1 question 4 is an exponential reduction question. Quite a lot of information given. The amount of substance remaining in solution reduces exponentially over time. Now this is a geometric series, AR to the power of n minus 1. An experiment measures the percentage of the substance remaining in the solution. The percentage is measured at the same time every day. The data collected over the first 4 days are given in the table below. Based on the data in the table, estimate which is the first day on which the percentage of the substance in the solution will be less than 0.01%. So to get my ratio, when we have term 1 is 95, that's A. A is equal to 95. Term 2 over term 1 gives me my ratio. So 42.75 over 95 is equal to, as a fraction, 9 over 20. So we have AR to the power of n minus 1 Tn, in this case, is equal to 95 by 9 over 20 to the power of n minus 1. And we're asked, when is this less than 0.01? So I divide by 9 over 20, or divide by 95, my 9 over 20 to the power of n minus 1. I'm going to use my log rules here. Less than 0.01 over 95. So using my log rules, n minus 1 by the log of 9 over 20 less than the log of 0.01 over 95. So now I'm dividing by the log of 9 over 20, which is negative. Just double check that in your calculator. It's between 0 and 1. So I'm going to need to reverse the inequality symbol. So I'm going to have the log of 0.01 over 95 divided by the log of 9 over 20. So n minus 1 will be greater than this. So just using the calculator, we're going to get n minus 1 greater than 11.4702, so 11.47. So n would have to be greater than 12.47. So we're asked on what day. Find the day, so it's on the 12th day, halfway through, just nearly halfway through the 12th day. We're not asked, normally we'd round n up to be 13, but it's on what day, so it's halfway through that 12th day, so on the 12th day. In part B of this question, we're given this square diagram with another square inside that and another square inside that, and the midpoints are joined to form another square. So that would mean this one is 1, this one is 1, this one is 1. So I can get this diagonal now. We know it's square root 2, but let's read the rest of the question. Find the sum of the perimeters. The process is to continue indefinitely. So this is the sum to infinity. And in the tables, a over 1 minus r, if you don't know it off by heart. So we need a, the first term, which we can see is going to be 8, and we need the ratio. So let's get a look at the ratio here. So this black side we have, I'll draw the triangle out, you can see that it's going to be root 2. So we have a 1, a 1 and a root 2. So now we have this square here. And the perimeter then of that one is going to be, they're all going to be root 2. So 4 of them is 4 root 2. So we could keep going if you wanted to get the perimeter of this one, but we just need the ratio term 2 over term 1. So let's just get term 2 over term 1. Term 2 over term 1 is 4 root 2 over 8, which is just going to be, not, I'm thinking 8 and writing, should be writing root 2. So 4 root 2 over 8, which is root 2 over 2, which is equal to 1 over root 2 or root 2 over 2, whichever you prefer to use. So sum to infinity, just calculator use from here. A, which is 8, divided by 1 minus 1 over root 2. And typing this into a calculator gives me an answer of 16 plus 8 root 2. Nice easy question. Question 4.